I want to ask you guys a question. If I said f of x is, let's do 1 over x plus 1. And remember, we were just in our notebooks yesterday. Didn't print. And g of x is 5 over x. If I asked you to do f composed with g of x. So yesterday we were doing compositions with numbers. But if I don't give you a number to plug in, think about what your composition means. It's saying you're doing f of g of x. And we always start on the inside. What is g of x? Okay, so I'm asking for f of 5 over x, which means you go to function f and you replace your x with 5 over x. Is it proper notation to leave a fraction in a fraction? So different options. You could get a common denominator, flip and multiply, but an easy option here, my denominator is x. So I could just multiply by x on both the top and bottom of my fraction. So if I do that on the top, 1 times x is x. On the bottom, 5 divided by x times x is 5, plus 1 times x is x. So my compositions, I can get an expression at the end. I don't just have to get a number. All right. What if I asked you for the domain of this? What does domain mean? What x can be. All right. What can x be? Okay. If we just look at this final answer, x can't be -5. Would we all agree with that? So you're saying the domain is everything except that. And that seems pretty reasonable. What if I asked you to find f of g of 0? Can I put a 0 into this final answer? This fraction? I can. I would get 0 divided by 5, which is 0. But what if I did it piece by piece? Can you do g of 0? No. Okay, so we have an issue. If I'm looking at the domain of these things, if I only look at the final answer, I'm missing something. Because we just found out by trying to plug it in, I also can't put in a 0. What would this one tell me I can't put in? -1. Let's check that. Can I put in -1? So if I put in -1, g of -1 gives me -5. So we have f of -5. Can you put a -5 into f? Yeah. And we get a -1/4. So the -1 was okay, but the 0 wasn't and the 5 wasn't. So, with the domains of these compositions, you cannot just look at the final answer. Sometimes that will give you the right answer, but sometimes you're going to miss something. So when we're finding the domains, we have to look 2 places. We have to look at the final answer, but also at the inside function, the first thing you plug in. Okay, because I saw right there that can't be 0. And I have to put these two together for my final domain. So for domains of compositions, you have to check the inside function and the final answer and put that together. So let's practice. We're going to do some compositions and find some domains today. Let's say I asked f of x is x squared plus 3x minus 1. G of x is 2x plus 3. If I ask for f composed with g, so that's f of g of x. Starting on the inside, g is 2x plus 3. So if I go to function f, every time we see an x, I'm replacing that with 2x plus 3. How do I do 2x plus 3 squared? That would give me a 4x squared plus 6x and plus 6x plus 12x plus 9. Distribute that 3, so plus 6x plus 9 minus 1. So we get 4x squared plus 18x plus 17. For my domain, what two places do I need to look? Okay. So if I look at my final answer, is there anything that x can't be? No. No fractions or radicals. If I look up here, is there anything x can't be? No. So overall, what's my domain? Let's do another one. Okay, I only asked you to find the domain of this, but I think it's easiest to find the domain if we actually do the composition. So we need f of g of x. G is 4 over x minus 1. F is 1 over whatever I plug in plus 2. So I'm putting in the 4 over x minus 1. Alright, bad notation. We can't leave that fraction in a fraction for our final answer. So we need an easy way to get rid of it. What would I have to multiply by if I wanted to eliminate that issue? So I'm going to take top and bottom of my fraction times x minus 1 1 times x minus 1 is x minus 1. 4 divided by x minus 1 times x minus 1 would just be 4. Plus 2 times my x minus 1. So that would give me a 2x minus 2 plus 4. So 2x plus 2. So for my domain, where do we have to look? Final answer. From my final answer, it's a fraction, so I know 2x plus 2 can't be 0. 2x can't be negative 2. So x can't be negative 1. And where else do we have to look? The original inside. So that tells me x minus 1 can't be 0, so x can't be 1. For your domain, in general, we like interval notation. If you are getting multiple values that x cannot equal, I am okay if you just tell me that x can't be those. If it's just one value, go ahead and write the interval. If it's more than one, the interval can get a little cumbersome. It's everything smaller than negative 1, between negative 1 and 1, and bigger than 1, so that gets a little cumbersome. So on this one, if it's more than 1, you can't just say for your domain x cannot equal those values. Is this one okay? Do you guys think you can try one on your own? I want you to find that domain. Okay, let's try it. So I'm asking f composed with g. So g is 2 over x. I have to plug that into f. F says you're going to do 3 over whatever you put in minus 1. And we are plugging in the 2 over x. So to get rid of the fraction in a fraction, what do we do?
Multiplied by x.
Everything gets multiplied by an x. So we get 3x on top. 2 divided by x times x is 2. 1 times x is x. Alright, for my domain, I look at the final answer. And I know right now that x cannot be what? 2. Because if I have a 2, when I do this composition, it's going to give me 0 on the bottom. But I also have to be able to get to this point. The very first thing you're going to do is plug it into function g. If I'm putting a number into function g, what can I not plug in?
0.
So my overall domain, x cannot be 0 or 2. So you can write it like that. If you chose to do the interval, it's everything smaller than 0, everything between 0 and 2, and everything bigger than 2. Okay, so you could do, I would accept either of those on that one. Let's try a couple more. I feel like we're not completely there yet. We're going to do this one both ways. I'm going to do f composed with g and g composed with f. So, f composed with g, that means f of g of x. Start start on the inside. What is g of x? So I'm going to function f, replace your x with 3x. So we get the square root of 3x minus 1. For my domain, if I look right here, anything under a square root has to be what? Bigger than 0. So 3x has to be bigger than 1. So x has to be greater than or equal to 1/3. Okay, but I have to be able to get to this point. So the very first thing I did is plug it into function g. G is 3 times x. What can I plug in there? Anything, right? There's no fraction, there's no square root. So I could plug in any number I want at the beginning, and at the end I just know it has to be bigger than or equal to 1/3. So my domain, when I put those together, is just 1/3 to infinity. Bracket on the 1/3, parenthesis on the infinity. If I ask you for g composed with f, we talked yesterday that order matters. This means g of f of x. So start on the inside, f of x is I plug that into g, 3 times the square root of x minus 1. So there's my composition. My domain. If I look at my final answer, what has to be true? Everything under the radical has to be greater than or equal to 0, so x is greater than or equal to 1. Okay, but we have to be able to get there, so if we look at our original inside, that was function f, what's the domain of that one? Same, isn't it? Okay. So my overall domain is 1 to infinity. What questions do you guys have? Do we need another one like this? Let's look at this. Actually, you said that. Let's go to this one. I want to find functions f and g such that f composed with g is equal to h if h is equal to x squared plus 1 to the 50th. So f composed with g, that means f of g of x. It's telling me you did this composition and you got x squared plus 1 to the 50th for your answer. Can you work backwards and tell me what your original functions might have been? Now on these problems, there are multiple correct answers. We have to give one possibility. So here's what I always look at. G is the inside. What's on the inside over here?
X squared plus 1.
So my g is x squared plus 1. Okay, think about what happens when you evaluate functions. If I say, f of g of x plus 1. Okay, you go to function g, you plug in an x plus 1, right? You get that answer, you go to function f, and you're replacing the x. So when we work backwards, think of it as when I take this back out, there was an x there to start this. So f would have to be x to the 50th power. Not the only possible answer. You could have done g equal to x squared, and f would have been x plus 1 to the 50th. So that's another possibility. Lots of different options. But the nice thing is you could check these. If we do f composed with g, will I get back that original problem? Let's do this one. F composed with g, that means f of g of x equals 1 over x plus 1. G is the inside. Okay, I don't have parentheses, so inside might be a little harder to think about, but if you were going to plug in a number for x, what would you do first? If I said x is 3, what would you do first? 3 plus 1, right? So my inside is like the bottom of that fraction. So I could say, okay, function g is x plus 1. So to get f, think about it, if I take out that x plus 1 and I put an x back in its spot, what do I have? No brackets. I want you guys to do one. So what was your g of x? What's your f of x? Did we all get that? Okay. Any questions about the stuff we've covered today? Is there anything you want me to review for your quiz tomorrow? Yes.
What all will the quiz be over?
So, like we were talking about at the beginning, parent functions and transformations. So you should be able to graph any of those main parent functions and their transformation. So if I give you something like -2 square root of x minus 3, could you graph the parent function and your final transformation? What would your parent function be? Square root graph. Remember, I expect some exact points. So the square root of 0 is 0. Square root of 1, square root of 4, square root of 9. So you should be able to do at least 3. And your parent function, we always did dashed. Transformation. Okay, what will that -2 do? The negative flips it, the 2 stretches it. We've talked a lot about if you struggle with that, anything on the outside changes x or y. Outside is y, and it does what it says. So if you struggle with that, work it out. Take these points and your y's times -2. Now, is that my entire transformation? No. The negative is flipping it, which we got. The 2 is stretching. What is that -3 going to do? So take our point, 0, 0, and then write 3. Okay, we said 1, 1 would move to 1, -2, and then write 3. 4, 2 is going to 4, -4, right? And your final graph from that. So you should be able to put the parent function and the transformation on there. Is that okay? We didn't have like a definite parent function, but we did talk about piecewise functions some. So make sure you could graph a piecewise function. So if I said 4 plus x less than or equal negative 3. The opposite of x. If negative 3 is less than x is less than or equal to 1. And 2x, x is greater than 1. First of all, do you know enough about reading that you could just evaluate things? If I said, tell me what f of 0 is. You know it's function, so you can only get out one answer. Which piece would you plug that into?
Negative 3 into x, negative 1.
0 is between negative 3 and 1, so you get out the opposite of what you plug in, so we get 0. If I asked you for f of 4, which piece would that get plugged into? The 2x. So 2 times 4 equals 8. If I said f of negative 3, which piece does that go into? First one. So 4 plus negative 3 is 1. So you could evaluate those. And you should be able to graph them as well. So remember, what did we do to graph these? We made t-charts. How many t-charts would it take? 3. So for the first one, you have to plug in negative 3 and then things smaller. So if I put in negative 3, I get 1, 0, negative 1. Remember, it started at negative 3 and it was for everything less, so this line, pretend I hit my point there, just went to the left. The middle piece, what do you have to plug in? You have to put in the negative 3 and the 1. Because the negative 3 didn't have an equal to, what does that mean about our graph? Open circle. And then you could put in something in between them. So you get out the opposite of x. Opposite of negative 3 is 3. Opposite of negative 1 is 1. Opposite of 1 is negative 1. Do we remember this? Am I going too fast? So if I plot them, negative 3, 3 was open. Negative 1, 1. 1, negative 1. This one didn't keep going in either direction, so it's just a segment from here to here. The last piece, what do you have to plug in first? 1. Open or closed? Open because it didn't have an equal to, and then we need things larger. So if I put in 1, I get 2. 2, 4. 3, 6. And that one kept going for everything greater than 1, so it extended on. So you should be able to graph a piecewise function. Remember, it's a function, so it has passive vertical line test at the end. Then, like homework from last night, evaluating like those questions where you had the graphs and you had to do like some f plus g of 4 or something like that. So you're reading the x value, finding the y's to add or subtract. And then the compositions, like we've been doing today, and their domains. So for today, I have a handout. It's much shorter than yesterday's handout. So you got time to finish that, and this stuff is on the quiz, so that'll give you good practice for those. Tomorrow we'll grade homework first, answer any questions. If there's something you need me to review, then I'll be happy to work it out.
Let's do that. Not double it. This was the first problem? Yeah, you can.
One.
Yeah. For one. Or two. It's like two things.
I don't know. It's fine.
So it's like this type thing, right?
Yeah.
Yeah, you got that.
Okay, wouldn't that be 6? Because
Okay, so when G is at 7, it's 6, but then you still have f of G. So if G equals 7, then you gotta plug it in. It might then restart.
okay, so yeah, so like because when G is 7, it's 6.
Yes,
So it'd be f of G.
yeah, and G
X.
equals, okay,
So, if you write it
I don't know how to explain it.
No, I just.
Literally just
So
takes
you
it.
go to G of 7. Multiply that. So when x is 7, now you have f of 6. So when x is 6, f is equal to.
I just didn't know how to explain that. I was drawing, I was like, I don't know.
No, it's not you. My brain is doing that on you already.
Absolutely. So, if you write this down, this is the same thing as
Oh.
the G of 7, right? Wait, so you did the answer G of 7. So when x is 7, function G is equal to x, or to 6. So that whole thing turns into a 6. So now you need f of 6. So when x is 6,
It's not. Oh.